Hello, my name is Bob Norman. In the previous demonstration of Labview for doing motor modeling with closed loop PID, I mentioned that I wanted to look at how you would compensate the slowest pull in the system with control. And another thing I wanted to take a look at was the motor load and the response to a load applied to the system, which would be a real-world application. I had a couple of days left on my evaluation software, so I had time to look at that. So as you can see here, we can do pole zero compensation. That really is a function of a PI controller if you think about it. So with the proportional and the integral components like this, you can rearrange and get something with a pole that's Ki over Kp. There's two poles in the motor system. One is mechanical that has a time constant of 0.1, the J over B. And the slower electrical time constant is 0.5 Henry over 1 ohm. So we want to compensate the slower electrical pole, which is accomplished by setting Ki over Kp equal to 0.5. So let's take a look at that, and we'll go ahead and take a look at applying a load to the system and how it responds. So here's our system. If you recall, we have a Kp, Ki, Kd. I'm going to zero out the Kd component, and here we have our feedback going around to enter the error. We start out with an initialized value of 0. Once again, I have times 10 here to take the transfer function of the motor, scale it by 10. So a unit step response here will be able to plot the actual response, and it should be approximately a response of 1. So we'll take a look at the control panel, and we're going to start out with an initialized system. We'll go ahead and run it, and when this point reaches the edge, I'll release the initialization. You can see that it comes up and hits the steady state value pretty quickly, and then we'll apply some load, and you can see that it recovers. What the actual load is like is dependent upon the overall system. This is just a simulated system, but here you can see this coming up. One way to think about it is a motor that comes up to speed, and when it's up to speed, a clutch may apply the load to the motor so that it hits this value of 1. Thank you again for watching my presentation on motor modeling in Labview and how to apply PID control.